Hi, this is JD and I am here with JStock. As promised, in my last video, I am here with another exciting topic. Yes, today I will be talking about autonomous or self-driven cars. Before I start, as usual, I request you to subscribe to my channel. Hey, this is going to get bigger by the day, so hit the notification bell icon to keep in touch and keep a tab on my future episodes. Please also like or dislike and put in your valuable comment. Do share my content if you like them. Imagine getting into a car, typing, or better yet speaking a location into your vehicle's interface, letting it drive to your destination while you read a book, surf the web, or nap. Self-driving vehicle, the stuff of science fiction, since the first roads were paved, are coming, and they are going to radically change what it is like to get from point A to point B. Now, autonomous vehicles, what is it? A self-driving car, also known as an autonomous vehicle, AV or auto, driverless car, or robocar, is a vehicle that is capable of sensing its environment and moving safely with little or no human input. Self-driving cars combine a variety of sensors to perceive their surroundings, such as a radar, lidar, sonar, GPS, orometry. Advanced control system interprets sensory information to identify appropriate navigation paths as well as obstacles and relevant signage. The primary means of implementing autonomous vehicle is using artificial intelligence. One of the most important systems of any autonomous vehicle is the perception system. Hence, it must be fully developed and well tested for autonomy to advance. The main purpose for the perception system is to constantly scan the surrounding environment and determine which objects in the environment pose a threat to the vehicle. The Society of Automotive Engineers currently defines 6 levels of driving automation. At level O, the car has no control over its operation and the human driver does all the driving. That is normal. At level 1, the vehicle's advanced driver assistance system can support the driver with either steering or accelerating and braking. At level 2, the advanced driver assistance system can oversee steering and accelerating and braking in some conditions, although the human driver is required to continue paying complete attention to the driving environment throughout the journey, while also performing the remaining of the necessary tasks. At level 3, the advanced driving system can perform all parts of the driving task in some conditions, but the human driver is required to be able to regain control when requested to do so by the ADS. In the remaining conditions, the human driver executes the necessary tasks. At level 4, the vehicle's advanced driving system can perform all driving tasks independently in certain conditions in which human attention is not required. Finally, level 5 involves full automation, whereby the vehicle's advanced driving system can perform all tasks in all conditions and no driving assistance is required from the human driver. 2. Autonomous versus automated versus self-driving. What is the difference? Let's understand. The Society of Automotive Engineers uses term automated instead of autonomous because a fully autonomous car would be self-aware and capable of making its own choices. For example, you say, drive me to work, but the car decides to take you to the beach instead. A fully automated car, however, would follow orders and then drive itself. Self-driving cars would fall under level 3, that is conditional driving automation, or level 4, that is high driving automation. They are subject to geofencing, unlike a fully autonomous level 5 car that could go anywhere. Point number 3. Areas of possible implementation of the technology. Autonomous technology includes personal self-driving vehicles, shared robotaxis, connected vehicle platoons, and long-distance trucking. Several projects to develop a fully self-driving commercial car are in various stages of development. To mention a few, Waymo became the first service provider to offer robotaxi rides to the general public in Phoenix, Arizona in 2020, while Tesla has said it will offer subscription-based full self-driving to private vehicle owners in 2021. Furthermore, the autonomous delivery company Nuro has been allowed to start commercial operation in California starting in 2021. Point number 4. Brief history of autonomous vehicles and initial hurdles. People have been dreaming about self-driving cars for a century, but the first vehicle that anyone really deemed autonomous was the Stanford cart, built in 1961. It could navigate around obstacles using cameras and an early version of artificial intelligence by the early 70s. In 1995, Carnegie Mellon researchers Todd Joachim and Dean Pomerleau drove across the country in Navlab 5, a 1990 Pontiac Transport rigged up to drive itself. In the early 2000s, the Defense Advanced Research Projects Agency, or DARPA, decided to accelerate self-driving development with an open to all comers race across the Mojave Desert. None of the finalists made it anywhere near the finish line, but the race created a new community of people interested in cracking the challenge. The best performance was Carnegie Mellon Sandstorm, a Humvee that used cameras, laser scanners, radars, and 1,000-pound box full of electronics to pick its way through tricky terrain. In 2005, 5 vehicles completed the course in the DARPA Grand Challenge. First among them was Stanford Stanley. The Volkswagen Touareg used a combo of cameras, radars, and laser scanners, but relied heavily on machine learning to understand what it was looking at and how to navigate. The third and the final DARPA contest was 2007 Urban Challenge on an abandoned Air Force base. This time, Carnegie Mellon, working with General Motors, took first place with Boss. The sensor-laden Chevy Tahoe used a new LiDAR laser scanning system made by Velodyne. In 2009, Google's Larry Page asked Sebastian Thrun, creator of Stanford Stanley, to build him a self-driving car and assigned him 1,000 miles of California roads. A year and a half later, Thrun's team had conquered the Larry 1000. For the next few years, Google dominated the self-driving conversation, gradually pushing the technology to a point where the auto industry could no longer ignore it. In 2014, it made clear its distaste for human drivers. With the Firefly, everyone else called it the koala or pot car. It was a vehicle without a steering wheel or pedals. 3 years later, after the self-driving team became Waymo, it retired in favor of Chrysler Pacifica minivans. In 2015, the big automakers were finally getting serious about autonomous tech. Mercedes-Benz, which had already done a lot of self-driving research in the 1980s, got seriously excited about the F015 luxury in motion. 11 years after helping Carnegie Mellon with DARPA's Urban Challenge, GM, that is General Motors, fully embraced the robo-future with a version of the Chevy Bolt EV that features neither steering wheel nor pedals. Meantime, Toyota explored that future with the e-Palette, a platform for a vehicle that can do everything from shuttling people to hauling pizzas to serving as a rolling hotel or medical center. It is one of the boldest declarations yet that we are moving to a world where vehicles are much, much more than things we drive. Volkswagen AG and Ford Motor Company vaulted into the pantheon of self-driving leaders by joining forces in July 2019 to jointly develop autonomous and electric vehicles. Volkswagen agreed to contribute US $2.6 billion to Agro AI, Ford's self-driving partner. That boosted the autonomous startups valuation to US $7 billion. Point number 5. What are the challenges with autonomous cars? It is taking longer than expected to get self-driving cars on the road. Self-driving cars rely on artificial intelligence to work. The 2010s were a great decade for AI. We saw big advances in translation, speech generation, computer vision, and object recognition and game playing. AI used to have a hard time identifying dogs in pictures. Now it is a trivial task. It is this progress in AI that drove the optimistic prediction for self-driving cars in the mid-2010s. Researchers anticipated that we could build on the amazing gains they had seen in other arenas. But when it came to self-driving cars, the limitations of those gains became very apparent. Even with extraordinary amount of time, money, and effort invested, no team could figure out how to have AI solve a real-world problem navigating our roads with the high degree of reliability needed. Much of the problem is the need for lots of training data. The ideal way to train a self-driving car would be to show it billion of hours of footage of real driving and use that to teach the computer good driving behavior. Fully autonomous or level 5 cars are undergoing testing in several pockets of the world, but none are yet available to the public. We are still years away from that. The challenges range from the technological and legislative to the environmental and philosophical. Here are just some of the unknowns. Let me explain. Number 1, LIDAR and radar. One needs to know that LIDAR is lot like radar, but instead of radio waves, it sends out millions of laser light signals per second and measures how long it takes for them to bounce back. This makes it possible to create a very high resolution picture of a car's surroundings and in all directions if it is placed in the right spot, like the top of a car. It maintains this position even in the dark since the sensors are their own light source. That is important because cameras are worse in the dark and radar and ultrasound are not as precise. LIDAR though is expensive and is still trying to strike the right balance between range and resolution. If multiple autonomous cars were to drive on the same road, would their LIDAR signals interfere with one another? And if multiple radio frequencies are available, will the frequency range be enough to support mass production of autonomous cars? Weather conditions. What happens when an autonomous car drives in heavy precipitation? If there is a layer of snow on the road, lane dividers disappear. How will the cameras and sensors track lane markings if the markings are obscured by water, oil, ice, or debris? Traffic conditions and laws. Will autonomous cars have trouble in tunnels or on bridges? How will they do in bumper to bumper traffic? Will autonomous cars be relegated to specific lane? Will they be granted carpool lane access? And what about the fleet of legacy cars still sharing the roadways for the next 20 to 30 years? Now, state versus federal regulation. The regulatory process in United States has recently shifted from federal guidance to state-by-state mandates for autonomous cars. Some states have even proposed a pre-mile tax on autonomous vehicles to prevent the rise of zombie cars driving around without passengers. Lawmakers have also written bills proposing that all autonomous cars must be zero-emission vehicles and have a panic button installed. But are the laws going to be different from state to state? Will you be able to cross state lines with autonomous cars? Next is accident liability. Who is liable for accidents caused by an autonomous car? The manufacturer or the human passenger? The latest blueprint suggests that a fully autonomous level 5 car will not have a dashboard or a steering wheel. So a human passenger would not even have the option to take control of the vehicle in an emergency. Next, artificial versus emotional intelligence. Human drivers rely on subtle cues and non-verbal communications like making eye contact with pedestrians or reading the facial expression and body language of other drivers to make split-second judgment calls and predict behavior. Will autonomous cars be able to replicate this connection? Will they have the same life-saving instincts as human drivers? Think. Now, 6. Benefits of autonomous cars. The scenarios for convenience and quality of life improvements are limitless. The elderly and the physically disabled would have independence. If your kids were at summer camp and forget their bathing suits and toothbrushes, the car could bring them the missing items. You could even send your dog to a veterinary appointment. But the real promise of autonomous car is the potential for dramatically lowering CO2 emissions. In a recent study, experts identified 3 trends that, if adopted concurrently, would unleash the full potential of autonomous car, vehicle automation, vehicle electrification, and ride sharing. By 2050, these 3 revolutions in urban transportation can bring about sweeping trends. Point 7. Fairyland stories shaping up into reality. I'd like to mention few of the major developments across the globe. These are all back to future stories. A. Hyundai is getting serious about building a walking car with 4 legs. B. Toyota teams up with Aurora and Denso on robotaxi development. C. Cruise and General Motors have entered a long-term strategic relationship with Microsoft to accelerate the commercialization of self-driving vehicles. D. The single passenger Cadillac from GM technically, a vertical takeoff and landing, in short VTOL, drone will be able to travel from urban rooftop to urban rooftop at speeds up to 55 miles per hour. E. Autonomous delivery startup Nuro can launch commercial driverless services on public roads in California. Nuro was founded in June 2016 by Google alums Dave Ferguson and Jiajun Zhu. F. Walmart and Gatik announced that they will launch fully driverless delivery trucks on a specific 2-mile, that is 3.2 kilometer route in Arkansas. Zoox Inc., owned by Amazon, unveiled a fully autonomous electric vehicle with no steering wheel that can drive day and night on a single charge. H. Cruise Automation, the autonomous vehicle subsidiary of General Motors, has started testing what it describes as fully driverless vehicles on public roads in San Francisco. Motional, a joint venture between Hyundai Motor Group and the driving software business Aptiv, revealed that its vehicles have been roaming the streets of Las Vegas without a driver at the wheel. The firm wants to unleash a widespread fleet of robotaxis in the next 3 years. J. Honda Motor Company Limited recently unveiled a partially self-driving Legend sedan in Japan, becoming the world's first car maker to sell a vehicle equipped with new certified level 3 automation technology. This is a few days ago. K. Cruise is teaming up with Walmart for robo delivery in Arizona. L. Daimler AG's commercial truck unit and Alphabet Inc's Waymo recently said they will collaborate on development of self-driving Class 8 semi-trucks. M. Drone truck startup Einride unveils new driverless vehicles for autonomous freight hauling. N. Mercedes-Benz and Nvidia team up to develop next generation supercomputers for cars. O. Volvo says it will roll out its self-driving highway feature dubbed Highway Pilot as part of its next big platform update. The scalable product architecture SPA2, which will arrive with the next generation XC90 SUV in 2022. SPA2 will also underpin the automaker's upcoming electric vehicle, the Polestar 3 SUV and the XC40 Recharge. P. All-electric Combi will be Volkswagen's first autonomous vehicle. Q. The ID.Buzz, essentially an all-electric updated version of what we in Australia know as the Volkswagen Combi, will be the first Volkswagen vehicle to feature self-driving technology and will be used for robotaxi services. R. Apple's worst kept secret, the Apple Car, is a self-driving electrical vehicle and being developed under Project Titan for a 2024 or later release. Rumors speculate that it will be a fully featured self-driving electric vehicle having AI specific features with Siri and will compete with Tesla and other EVs. Apple has acquired Driver.ai in 2019 and could partner with other popular manufacturers like Hyundai or BMW or seek other options. 8. Who has got the edge? Tesla or Google's Waymo? Google is a search engine giant and a technology company specializing in all facets of IT. Google's self-driving project is Waymo, a subsidiary of Alphabet. Tesla is an American automotive and energy company which specializes in electric cars and solar and specific technology and is led by the visionary entrepreneur Elon Musk. Waymo has an extensive experience in AI deep learning, which is the heart of the autonomous vehicles, perhaps more than any of its competitors in the autonomous vehicle commercialization race, including Tesla. On top of it, Google has more complete engineering experience in building an OS for autonomous vehicles than probably any other company. Tesla, on the other hand, earned quite a reputation for itself for producing an all-electric luxury car from scratch using mostly Tesla design components and autopilot software coded by Tesla engineers. Waymo uses a very expensive in-house 64-beam LiDAR, the heart of the system, which is mounted on the roof of the car, and it sends 64 beams of light to get information about the terrain. By combining real-time information from LiDAR and other sensors, including cameras with high-resolution maps of the road, it generates a 360-degree world model to predict movements for nearby vehicles while avoiding obstacles and following traffic rules. Tesla, on the other hand, does not use LiDAR but relies heavily on computer vision for building a virtual picture of the surroundings using the forward-looking camera technology from Mobileye, the largest supplier of camera-based driver assistance safety system. While both Waymo and Tesla are doing everything to collect and process data to make a fully autonomous vehicle that can drive all by itself without any human interference, they have different approaches for data processing. Google uses powerful computer simulations and feeds from its fleet of cars that are in testing on real streets. Tesla, on the other hand, relies on the real world data collected from the hundreds of thousands of Tesla's drivers, human drivers in fact, people who are using Teslas and driving on the roads. Who do you think will end up delivering the perfectly working autonomous vehicle first to this world?